Good. Afternoon, everybody. I'm George Matos.
And I'm Tom Cowland.
And we're going to talk about Bunsen. So we're kind of updating from last year, where we're at. And, well, we'll get to it, and then we'll do some stuff at the end here. So a little background on Bunsen itself. So for those that don't know the Foundry, basically 21 years the Foundry's been helping the M&E industry kind of build tools and pipelines to automate and streamline. Because of that, a few years ago, basically various people within a few industries, including the architecture, engineering, and construction, came to us and were saying, is there any ability for you guys to kind of help create a pipeline where it doesn't exist? So that's kind of where all of this started. And what is Bunsen exactly? So the idea of Bunsen is we take some data in, and once that data comes into us, we're doing some different things than people are used to in this sense. So we're caring about metadata and geometric data because we filter things, we reduce polys, we assign materials, combine, and we create various exports. Now, some of this is automated. For things that the automation doesn't fix, we give you the ability to basically go out and fix it manually. And then, because of that metadata, by using it, we can leverage things to basically help do things much quicker than you would in a manual process. And part of that is we can output to files, data. We can output to AR, VR, MR experiences, renderings, and other mediums. And this can all be done individually, or you can do it all at one time.
Cool. So we've talked about pipelines, but what exactly does a pipeline mean? Because it might be a new sort of term around. So whenever you're producing a visualization, so in this case we're going to take the example of some data from Revit. We're wanting to do a high resolution still and perhaps an experience for a headset or other real-time thing. Maybe to build that we need to swap out some of the placeholder geometry that's in there, remove some details. But the steps that you need to go through aren't necessarily defined anywhere. They're probably in the heads of the artists, and that's the talent and skills that the visualization team have, is being able to do this. But it could be different between different people, and quite often work is repeated many times over. So the idea of a pipeline is about creating a flowchart that describes what has to happen to get you from your source data to these various products that you're trying to produce. But as part of describing these steps, if we're able to describe rules that say when these things should happen, we start to build a repeatable series of operations. So maybe replacing chairs, we could look at a specific Revit family and say every time you see that family, swap it with this model that we've made that is either more accurate or doesn't have some of the damaged geometry that we sometimes see coming from these source applications. Maybe we can simply use a discipline or other properties to remove some of the complex sort of engineering-y type parts that might be behind a wall and so on. So we end up with this flowchart and this sort of recipe for this processing. And why this is interesting is if you have some new source data, you can simply feed it through the same series of steps that can be run by the software as set up by the Viz department. So hopefully it allows you to sort of save people repeating themselves over as designs change, or maybe you can take some steps that you used on a project and move them on to the next one where you have some different sources or some different flows that need to happen. So Bunsen lets you build a pipeline for your data that you can easily change per project or build standards that work across. So here we're sort of seeing the node graph, which is how you define these steps. Each of the blocks are some kind of processing step. As we go down from the top to the bottom here, the data flows downwards, and we start off with some generic repairing of the models, lighting and material type things, reduction of the data set down to perhaps a specific focus, and then you see we have a little branch. So, for example, going to real-time may need some additional optimizations that we don't need to do for sort of a final quality renderer such as iRay.
So how does Bunsen work? This is not something that's installed on a workstation. So we have two deployment options, you could say. Basically, what's called a provision secure infrastructure. So the ability for you to scale. There's no hardware costs, right, for you to take on yourself. It is secure. There's no public access. But then there's other people and sometimes projects that say, no, we need an actual air-gapped solution. So there is an appliance that you can get as well. So both solutions or one or the other type situation.
And one of the reasons we sort of go for this approach is we don't want you to have the overhead of maintaining a complex software stack, because you can start to automate these things. There's a lot of moving parts within the system, so it's about providing you a solution rather than 16 installers and a complicated set of steps you have to follow to get it up and running. But once you actually have this integrated into your network, whichever route you're choosing, it's not really any different from the software that you're using right now. So the idea is perhaps if you were working from the Revit case, you'll make your exports, you'll save it on your storage as you do with your existing workflows. This can then be accessed from the appliance, and then the Viz team, using sort of a thin client kind of approach, can interact with the appliance, set up the processing they need, which is talking back to your storage again, so your data stays in a safe place. And then when your products are made, they go back into your domain as well. So you can kind of think of it really as this, and use it in the same way as you would do, except you don't have the overhead of maintaining this, the stack of hardware to provide it. And this is then flows back to the rest of your company, and people can use the products.
So what type of data? Basically, the 3 data pieces we'll use to start that we've written kind of first-class exporters are for Revit, Rhino, and SketchUp, and then we have kind of standard formats that are used across industries. So these are the 7 types we're basically looking at right now. And then the types of outputs. So Bunsen is we've selected NVIDIA's Iray as the default rendering engine. So in this case, we're producing a Pano 360 as one output. We're producing an IMP still frame. Could be animations. Then as we go, we can produce also an Unreal experience. So we can feed the data directly into Unreal Engine. Then we also have the ability, where we talked about earlier, about saying this manual process, we can output to files. So we have a few options for outputs.
Yeah, we know these steps can be quite tricky sometimes. There's a lot of work to do. So what we're trying to do is provide tools to help the artists get this work done quicker and more efficiently. We're not trying to replace them the thing they're doing, but simply make it easier and quicker for them to do what they need. So there's a bunch of steps that we've kind of tried to support a little bit. One of the first things we've done is the reason we've created these first-class integrations into some of the source applications is to get you better data out of there in the first place. So some of you may have seen this before. We found if you took the native FBX Revit export, you quite often get these little sort of crushed polygons with cylinders and things that need a lot of manual cleanup. We were able, with a bit of work, to get something with a better consistency out the gate without increasing the weight of the models too much. So hopefully that removes some of the cleanup that you have to do manually later. But the second reason is to make sure we preserve all of the metadata and other properties and annotations that you have attached to these items. When we talked before about it being a rules-based pipeline, in order to build a rule, you have to have some criteria by which you can sort of define this process. So you can see here all of the properties that were in Revit for light fitting. So, for example, you could easily find and create rules that might pick lights by a certain manufacturer, or there's some electrical qualities that are stored in here. So there's all sorts of things that can be used to drive the process as you move forward. There's tools for doing sort of look development, material work, and so on. So on the left is our sort of auto-converted, using the data that was in the Revit model. This model didn't have a lot of materials assigned or anything like that. So using the tools within the platform, you can sort of kind of address that into some slightly bizarre modern style hotel room. You can also convert materials sort of automatically, which we touched on a little before. So you could either say take the Revit materials and convert them to another target of your choice. But in this case, someone had been making an interactive experience for a hospital operation room where they wanted to do some practitioner participation tests to learn about the layouts in the space. And then they needed to do a high-resolution stills rendering, so we just basically auto-generated the whole Iray setup straight from what had been configured for Unreal. On the subject of real-time, quite often you need to make sure you can reduce the complexity of a model. So in this case, we're seeing our poly reduction stuff being applied with a couple of different settings to one of the chair models that was coming through. It was quite high to start with. But you could also use this to automatically create multiple levels of detail if you needed to in the same time. Or you could drive, because of the rules nature, you could drive how much it's reduced by perhaps how far away it is from your rendering point or such things like that. We can also sort of do mesh combination to help reduce the draw calls that you get and help keep that frame rate that you need to stop people feeling slightly nauseous when in these VR type environments. So in this case, this is looking at a hospital model we'll see a little bit more of later, but getting it down from sort of 12,000 discrete components to a far more manageable number.
And then, so this is another experience that was created, and the idea is to try to make it an actual collaborative and experiential. So not just walking around, you have collaboration, but also making it interactive. So in this case, we're showing the ability to kind of move things, but also think of it as changing materials, changing walls, moving objects, and things like that.
There's going to be lots of interesting stuff coming in there down the line.
Yes. And one more thing. So we've talked about all this piece, and we've talked about trying to automate some of this stuff. So one of those pieces is actually something we've come up with saying one-click VR. So in this case, what we're saying is inside of Revit, we'll have another plugin. And what we're doing is we have some presets. In this case, we're saying it's museum board. But the idea is that instead of the architects or the designers having to go bother to design Viz people, what we're actually doing is saying, okay, if we give the ability to the architects to have this plugin, it can still go through the Bunsen process, automated. They basically call it up with various presets, and they can go around, walk around basically as like a spatial awareness tool. There'll be some colors, some materials that come in, but then the other option that you see down there is the design Viz artist is basically working on this in the background. That person is then creating more presets or working on it in real time, and at any given time, the designer architect can actually just say, I want to see what they're up to, and get the VR experience right away.
So they get the full fidelity and all of the improvements to the look and the replacement models that might have been set up by the Viz team, but without having to, like George was saying, trouble them and give them a massive backlog of work just to get a review out to client.
And one more piece to this is also that by doing this, it's also trying to create a company standard as far as visualization goes. They're using one platform to basically produce the VR versus some firms that have 4 or 5 different VR platforms, depending on the user. So this is a question, obviously, that will come up is, when is Bunsen going to be available? We'll be announcing commercial timeline later this year as far as alpha, beta, and launch from there. So that's kind of the info piece. Now what we did is we worked with one of our clients that we've been talking to about this. Unfortunately, she wasn't able to be here, so this is Shum, a project that they did, and she was able to actually record a video, so we're going to watch a little video from Hilda.
Hi everyone, my name is Hilda Espinal, and I am the Chief Technology Officer for an architecture, engineering, and construction firm by the name of Cowland Design. Cowland Design has a presence in 16 different cities across the globe. We are over 100 years old, and despite our tenure in the industry, we very recently were awarded being one of the top 10 most innovative firms by Fast Company. I am very pleased to join you today virtually to share one of our most successful and prominent projects, this being the largest project in construction today in North America, Center for Healthcare by the University of Montreal. The project spans 2 city blocks, is over 3 million square feet, and it translates into over 160 Revit models in the digital space. The project is nearing phase 1 and completion, and as we enter phase 2, Cowland Design and our partners, Noof Architects, are looking for ways in which we can bring more value to the project in having our clients be further involved in the decision-making process. From my perspective, this can be very much facilitated with technology in leveraging not only the high-resolution renderings that we use up until now, but introducing the ability to be immersed in the space by experimenting with virtual reality and augmented reality. This brings to surface our collaboration with Bunsen, as it promises to be a technology that can help streamline the massive amounts of data and information that our talented visualization artists spend a lot of time cleaning up and setting up in order to get the output that we require, and actually have them focus more on optimizing images, which is where their talent and passion lies, and using the technology to be able to reduce the effort without, which is very important, not reducing the quality of the output. I'm also very excited to partner with Bunsen and continue to kick the tires as the technology continues to evolve, because it also allows us to give this ability to a larger group of designers in our 1,000 people firm, and we don't necessarily need to limit the ability to create these high-end visualizations only to a few that are only dedicated to producing this type of work. Last but not least, I'm also very interested in leveraging its rules-based technology and being able to take rules that we create for the generation of high-quality imagery and being able to reuse it as we inevitably make changes to the design without having to throw everything away, which is the process that we've had to use up until now, and reuse these rules in order to generate the visualizations from these alterations. Once again, you will be able to hopefully experience the spaces of our project today in virtual reality. I hope you enjoy the experience, and I appreciate your time and attention.
So thanks to Hilda for that. So we're going to walk through a little bit of a study we did with them. So this is part of the hospital in Revit. And then what we're doing is we're going to basically say that part of the phase 1 project, we're going to narrow it down to this kind of area that they've focused on.
So a key feature of the architecture of the platform is the ability to selectively load parts of a very large data set. So if you take the whole model for the site and everything, there's kind of 77 million polys here, and there's about getting on for 500,000 discrete objects in this whole data set. And that's kind of a lot to deal with in many ways. So don't worry, what you're seeing here is not the entire data set, but we're using the ability to selectively load parts of the model for display. So we've just asked Bunsen to load up just the curtain panels, the walls, and the site model to help get a context of where this data set extends to and help us then drill down into the areas that we need to. This is great for artists because it means if they're working on a specific section, so say for example here, we're going to load in a filtered set down to a view over the cafeteria. You'll notice things load up in the background as the application's running. So gone is the 20-minute progress bar that comes up, which is probably not good for your local coffee shop's revenues, but saves that kind of long wait if all you want to do is make a simple tweak. So on this project, there was some creative direction that was indicating some of the areas of this model that were needed for specific camera angles or viewpoints. So we're again using this sort of lazy loading or deferred loading technique to create some bounding volumes of perhaps interest. So here, again, we're just using the walls as a quick way to explore the set because they load up fairly quickly and are fairly low complexity. And we're creating regions of space that we're interested in. I mean, the Revit folks here, it's kind of like the scope boxes that you can set up there. We also have tools that allow you to filter based on view and other such criteria. So in this case, it's showing the selective reloading of the model based on the camera position, and this was used in the renderings to get rid of all of the detailed equipment, such as the fire alarms and the sprinklers and all the bits you don't need outside of the view range. So you don't have to manually go and keep an eye on that if you had change your camera angle or move around. So once we've sort of filtered this down to a manageable area, this is our interactive iRay integration, which is it's also showing sort of the power and speed of sort of cloud-based rendering options when you can integrate that. And here this is showing the automatic conversion of the Revit model being rendered through that platform. We then created an interactive, a basic UE experience so that we could have a little look around for an inspection of the quality of the model and help learn about what we need to fix up for the area that's going to be navigated in the final experience. So it's a much easier way to look for missing and bad geometry than it is to try and drive through a 2D space in the mouse. One of the things that was kind of identified there as well is because all of the chairs and tables were laid out in a very metric and grid-like fashion, we wanted to add a little more variation to make it feel slightly more lived in. So there's tools inside of Bunsen to quickly and easily procedurally create variation in your model where you need to help bring a bit more of a lifelike feel to it.
So with some work, we've basically made a little bit more kind of early days renderings here, utilizing iRay quickly to basically help them kind of walk through the space. I believe these, again, the power of the cloud, we were able to do pretty much, I think we did about 50 of these in about a half hour, to give you an idea.
It's about 10 seconds of frame movement.
Yeah. So, and then here we just created a Pano 360, just a click of a button, comes out. Then now, so we have the still side, we go offline. Now we want to go to engine. So part of that going to engine piece is, as we said, optimizing, right? So part of this is we have many objects, hundreds of objects. What we need to do now is basically use a rule, and we're going to basically kind of combine this stuff down to 10 to 20 basic objects to make it easier, right? For the rendering side, didn't need to do it. Now going to engine, we actually do. So going to this, we basically push this into Unreal. There's some tweaks that had to be done once you put it into Unreal. So as you walk through here, this is a recording of actually walking through. And we come into the space to basically do things like, tweaking to open the doors, maybe tweak settings and lighting, add some experiences.
That were outside
the cars, yeah. And as we come in here, an interesting piece is, as you'll see, you're not the only one in the experience. There's actually someone else in here. Now, it could be somebody else in a Vive. It could actually be somebody on a mobile device, tablet, phone. And as we go through here, now this is an example of experiences, right? So we can change floors, we can change lighting, we can change, there's other things up there, we can change the layout of the tables, different options, and down the road there could be options to record some of that data to get it out. There could be options to notate various things. This is an example think of it as a preset. There could be others, but it comes standard. So as part of this, when we're done, on the back side of the booth, we actually have this set up that everybody can go and experience it and go through it themselves.
And sort of lastly, a little sort of call out we like to do is we thought it'd be fun to kind of recreate the original architectural model that they probably did at some point in this. So we took exactly the same data set that the huge source model, filtered it down in a different way, and applied a whole set of different treatments to the look and the style of it, scaled it down and shoved it on the table in the cafe. So it's basically the same data set going through a couple of different rule sets, and you can mix and match this. This could even be bringing things from different sources if you need to. It really is kind of like just a big data aggregation and sort of filtering environment too.
Think of it as, for any architects out there, architectural model, instead of walking around it physically, you could walk around it virtually. So a little just fun toy we did. So I want to thank our partners that were involved in helping us with everything today. And basically what we're going to do is kind of break. Tom and I will answer any questions. We have the stuff in the background, and we want to thank Google Cloud for basically providing the cocktails. So everybody get a drink, and we'll talk. So thank you.
Thank you.